Hello everybody and welcome to this webinar on the FiberPlanIT Engineer, our latest product which we will be showcasing today. My name is Jonas Verstuyft. I'll be presenting today and I am the marketing manager at Comsof for FiberPlanIT. Let me start off by going through the agenda for today. So we will start with a short introduction on FiberPlanIT and Comsof. Then I'll go into some more detail on planning and design concepts and the workflow of an FTTx project. So we know where to situate this webinar of today. And then we will go into more detail on the actual network design, where we will show the high-level design with the FiberPlanIT Designer, and then the low-level design with the FiberPlanIT Engineer. So for both tools, we'll see a short demonstration in this webinar. Then at the end of the webinar, there will be some time for a Q&A session. In total, I expect this webinar to take around 45 minutes. At the right-hand side of your screen, normally, there's a GoToWebinar Q&A window where you can ask your questions throughout the webinar. And at the end, I'll go through them and try to answer as many as possible. If I do not get to your question, I will definitely follow up via email afterwards. Then after the webinar, you will be redirected to a web page with a short survey. It would be highly appreciated if you could take a few minutes to answer the questions. This is very helpful for us. Then later this week, so tomorrow normally, you can expect an email with a link to the recording of the session, so that you can watch it again or share it with any of your colleagues. Now, let's start with a short introduction on the company Comsof. So we're based in Ghent in Belgium and started off in 1998. And since last year, we opened an office in Toronto in Canada to serve the American region. Then since 2008, we're mainly focused on FiberPlanIT, so on FTTx network planning and design more in general. And we use FiberPlanIT both in our own planning and design services that we offer, or as a software solution that our customers can use. With the tool, we've done more than 200 projects worldwide in more than 40 countries, each time trying to adapt a solution to make it more flexible and more applicable for any architectures that we come across. Now, let's start off with taking a look at the workflow for an FTTx project from planning up until operational stage. So the beginning of your project, you have the strategic planning stage where you need to decide on the type of architecture that you will use, whether you go for fiber to the home deployment or maybe G.fast or DOCSIS 3.1 if you have existing infrastructure, or maybe fiber to the building. So these kind of decisions need to be made early on in your project. Also, you need to decide on which regions you want to deploy at first. So quite important decisions to make. We won't be handling that topic in the webinar today. We have a solution for this stage, FiberPlanIT Simulator, where you can easily compare the costs of different architectures, different regions that or areas that you're looking at to deploy. We've covered this in other webinars, and if you're interested, I can definitely send you those recordings, or we can schedule a demonstration for your particular project. Now, what we will focus on is more the design stage. So after you've made a decision on your architecture and the area which you want to deploy your network at, you need to do a design for that area. So you need to decide where your fiber concentration points will be placed, your cabinets, how you will route your cables, where will you do trenching, where will you go aerial, can you reuse existing infrastructure, how do you route your cables. Also, which cable sizes do you need to use to connect all the homes in your area. So that's the initial design stage. Once you have your design ready, following the architecture you have in mind, of course, you need to go into the field and verify that the design that you've come up with is actually constructible. So you need to do a field survey, and any corrections that you still need to make need to be fed back into your design. So you need to fine-tune your high-level design, maybe reroute some cables, or place your cabinet at more suitable locations. Now, with this constructible high-level design, so only the cables and ducts that you need to use, you need your to-build plan to actually go to construction. So you need to know the fiber level connectivity, you need to know which cables to place and which ducts or which microducts. So a lot more detail than you would need in your high-level design if you're just looking how you want to deploy your architecture. Now, with that to-build plan, you can go to construction, you can build your network. There can still be changes during deployment, and those changes will need to be documented in your physical network inventory solution, or the inventory solution of your customer in case you're contracting a company. So that's then your as-built plan. Now, what we will focus on in this webinar is the design stages, So the high-level design with the FiberPlanIT Designer, and the low-level design with the engineer. Now, let's first take a look at an alternative, which is to do your design manually on pen and paper or in a GIS tool, but by drawing your network by hand. Now, first of all, doing a design following the architecture, applying it to the area, is quite a complex process. There are a lot of factors to take into account, and doing the drawing is time-consuming. It's a time-consuming job to make sure that your network design is correct, that all the homes are being fed correctly, and it's quite repetitive, a repetitive task as well. Because of all of these factors, it's quite likely that there will be some smaller errors in your plan, which can have big effect if it's only discovered at later stages, maybe even only when you go want to activate a customer. So this can have huge cost implications on your project. Another problem with manual design is, how do you know that you deploy or design your architecture in the cheapest possible way? The design that you come up with can maybe follow the architectural guidelines, but there are so many decisions to make during a design that you're never sure that it's the cheapest way to deploy it. And even a small couple of percentages less trenching, less cabling can have a huge impact, and can save you a lot of money. Now, that's why we have FiberPlanIT, where we use automation and optimization algorithms to save you time during the design, during the deployment, and save you costs as well. So come up with cheaper designs, more uniform designs which are easier to deploy. So during all the different stages you can save time and money with FiberPlanIT. Alright, so let's go into more detail of the actual design stage with FiberPlanIT. So what we need for FiberPlanIT is we need to know which area where you want to deploy your network. So you need to load in your buildings in case of a fiber to the home network or fiber to the building, and any existing infrastructure that you might reuse, including the street layout, so that FiberPlanIT can decide on new trenching if needed. So that's the basic input data needed for design with FiberPlanIT. Now, if we look at the high-level design with the designer, there you can configure the network architecture that you want to use for your high-level design. So you configure the size of cabinet areas, the type of cables, type of ducts to use, whether it's a PON or point-to-point network. And then the designer, FiberPlanIT designer, will apply those rules and architectures on your area and come up with an initial high-level design. Now, with FiberPlanIT, it's very easy to iterate your design. So, like I said in the few slides back, where you have your planning and design workflow, you will have to do a field survey with your initial design to make sure that it's constructible. So with the FiberPlanIT design, you can easily make changes and recalculate your network. So change the location of cabinets, for example, exclude certain crossings, street crossings which are not possible, or street trenches, and then simply recalculate your network. And as it's an automated solution, this is done instantly. Now let's take a look at a demonstration of the designer, some more detail. So we'll look a bit at the design preparation, so the JAS data that's loaded, configuring the architecture, setting the equipment that can be used. Also take a look at the output that is being generated by the tool, and then also indicate how you can adjust this to field input and iterate your design. All right, so what we see here is a particular area which I prepared to do a design on. So what do we see? We have our building layouts, our building entry points which are loaded. We have the street layout, and we have some existing infrastructure, existing pipes, which can be reused. Now this serves as input data for your network design. In case of a greenfield deployment, of course, you won't have any existing pipes, so it's not mandatory to load these. Now, in the designer, to prepare your area, we have a set of pre-processing steps. So set of functions that help you to process your area, to come up with the potential routes which can be used for doing a design. So both for aerial, buried, we have these kind of steps. And what this does is come up with all the potential routes which can be used for deploying your network. So we see a lot of street crossings, for example, a lot of trenches which can be used that are generated based on the street network layout. Of course, we will see in the final design that not all of these potential routes are being used. But by generating these and giving the possibility to edit this, we give a lot of flexibility to the user to come up with a design which is constructible in his region. So all of the crossings you see here, all of the trenching, can be included or excluded from your design, which makes it very flexible. Of course, for your initial design, you can start off with all the potential routes, and after field survey, you can still make these edits. Now, in FiberPlanIT, you need to specify the design rules that need to be used, that need to be applied to your area. So you configure which type of architecture you want to use. So in this case, we say we want to do a point-to-point fiber to the home calculation. Of course, you can also change this and do a PON, deploy a PON network, indicate where you want your splitters to be located. Part of the flexibility of the tool is, and what is one of the strong points of the tool is the optimization functionality based on cost input data. So what we generated in our area preparation was all the potential routes, and what you can do as a user is assign a cost to every potential route that can be used. So for what we generated based on the street, so you have your standard trenching, street side trenching and crossing, where you assign a cost, and then we also had our existing pipes where we have a cheaper cost. So all of this information is used for determining the routing of the cables to come up with the most cost-effective route for your network deployment. What you also see is that you can indicate maybe cheaper or more expensive routes that you know of. For example, doing trenching in a pod is cheaper than doing the standard trenching next to the street. So by providing the possibility to enter all of this specific information, you can optimize the routing of your cables and save a lot of costs in your network deployment. Now, next to this kind of general information that needs to be provided, you can also load in the type of ducts, type of cables that can be used, and this is provided per network layer. So here we look at the feeder cables that we can use and the feeder ducts that can be used, including the price for material and labor to use this type of equipment, which is again important for the calculation of cost-optimized network, but also for generating the bill of material, which is presented afterwards. So for each layer of the network, we have a set of specifications that can be configured based on typical network architectures that are seen around the world. Now, after doing a calculation, and I've prepared this beforehand, what the software, like I said, what the software does is it applies the architecture to your area. So what we see here is a result of a network calculation, where you see every building being connected by cable back to our distribution point here, and then with our central office at this location, this is feeding every distribution point in our area. Level of detail that's being provided by the software in our high-level design stage is for each cable, of course, you know the cable type, so the size of the cable that's being used. Next to this high-level design layout of the network, we also generate a bill of material. So in our bill of material, you can see a detailed breakdown of all the different works and equipment that need to be used to build the network as it was designed. You can see the volume for each type of trenching in this example, so almost 7 kilometers of residential trenching with this total cost. So for each layer of the network, you can see the total volume for each type of equipment and the total cost. You can also get a summary of the cost to deploy your network, which can be very useful to compare different architectures of different areas to see what's the deployment cost per home pass, for example, for my different target areas. Now, with this initial design, you can go to a field survey and can still make edits. Like I said, you can exclude certain crossing locations or trenching locations which are not possible and recalculate. What you can also do is change the location of distribution points where cabinet might be placed or maybe placed in a manhole. Change this location to a more suitable location and then recalculate your network so that all the cables are being rerouted and you have a newly optimized network, taking into account the constraints that you've put in place. Okay. So that's a short introduction to the designer. So if we go through the benefits that you can experience with the designers, you can have cheaper deployments. So there's cost optimization algorithms built into the software that lower the deployment cost, optimize the routing of the cables and such. And of course, because you configure the type of architecture that needs to be applied. If you have many different designers working on different areas, if they all use the same set of architectures, you will get uniform designs across these different designers, which helps you to speed up the deployment, making sure that you can assure that every single deployment will be done in a similar way, following the same uniform design rules. That speeds up the deployment, saves in deployment cost. Also, you get a lower design time with the software. So because of the automation, so by automating the design process, by not having to manually draw all the equipment, but by generating the design, generating the bill of material, this saves you a lot of time and will allow you to go to the market faster. And also important is, design is an iterative process, so you need full control over your design and how everything is where everything is being placed, which type of equipment that is being used. So with the designer, you have that complete control and you can adjust to field input where needed, restricting routes or changing the locations of particular equipment. So that was the first step in our design process. Now, with this high-level design, we can go and continue our work to make all the necessary plans and documents that we need to go and do construction. And for this, we introduce the FiberPlanIT Engineer, where again, with a set of rules and configuration, you can guarantee uniform deployment plans. So in the engineer, you have the ability to configure the naming that needs to be applied to equipment. You can configure the splicing rules that need to be used, and also the coloring of cables, of ducts is configurable in the solution. And then when doing the transformation from the high-level design to your to-build plan, or from your high-level design to your low-level design, all of these naming configurations and splicing configurations are applied to your design, and gives you your fiber level connectivity from central office to each endpoint location, as we will see in the demonstration as well, and allows you to then generate your all your construction documents which are needed for your field teams to go out and deploy your network. Now let's take a look at demonstration of the engineer. So what we will go into detail of is how to configure your import. So we'll take a look at the naming configuration of the equipment. Then also we'll look at the results. So of a low-level design which is fully connected, we can look at the connectivity overview, verify the full attenuation loss, full connectivity from central office to each building. We'll look at a couple of diagrams and plans we can get from the tool. And most importantly, we'll take a look at documentation pack, which allows you to generate all of the plans, all of the reports in one go for your complete project, helping you to speed up the time and have that uniformity that you need for the construction teams. All right, so let's take a look. So this is our high-level design that I showed you earlier. Now we can convert this high-level design into a low-level design, and what we can configure in the solution is we can easily configure the naming of the equipment. So from our high-level design, we get a list of cables for each layer. So we have our feeder cable, distribution cable, drop cables. And by easily using templates and placeholders, you can specify the naming that needs to be applied to each cable. So there's a set of placeholders that you can use to do this. And then you know that for your low-level design, for your to-build plans, the naming will be applied in a uniform way throughout your network design. So both for cables, ducts, the clusters that are being generated. So you can see that for each distribution point, for example, there's a cluster assigned to this, indicating which homes are connected to this distribution point. So this makes it very easy, very flexible to configure your naming rules into the solution to apply to your high-level design. Now, if we take a look at a imported design, it looks, yeah, quite the same, of course, except that now we have our full connectivity, fiber level connectivity throughout the network. So everything, all the cables are spliced together. The cables are assigned to ducts, microducts, and we have our naming, which is applied. So if you take a look, for example, at our distribution point here, see, this is a distribution point closure with this this name. We have our incoming cables, which are all labeled, and our outgoing cables, which are all labeled. So that's everything that's being done during the import, which takes for this area of around, I think, 800 buildings, takes around 5 minutes to apply. So if we take a look at the connectivity overview for this design, we can see so for every single home in the area, we can see the connectivity from our central office location. We can track the path, see which cable is being used, so the label for the cable going into distribution point, and then the cable leaving that distribution point to our endpoint location, which with this address. And with this tracing now available, we can see, okay, what's the total loss, what's the path length for this end-to-end connection. So we get much more detailed information than that we get in our high-level design, where we only have the cables and the ducts available and the routes. But at that stage, it's not needed. But once we go into construction, of course, we need that detailed information. Now, we can also take a look at one particular address and see what the connection looks like from our central office to our demand point or end point, in this case the home. We can see the full path, so we can track which cable is being used. So in this case, a 144 fiber cable, fiber 70 is being spliced at distribution point 1.0, being spliced on fiber 2 back to our, that's running to our endpoint. So the full all of the naming which I showed you that is configurable is applied. Also the coloring of the fibers is available at this stage, which is also configurable. So based on the cables that you will use in your project, you can configure this, and also the splicing rules which are configurable, which we will see if we take a look at a particular distribution point closure, for example. So if we take a look here, we can again show the connectivity in a different format, indicating how all of the cables are connected to the outgoing cables in this particular closure. So what we see here are our fiber bundles, which are coming from our central office. Then these are being spliced in our trays in the distribution point, and we have our outgoing cables which run to the home, all the homes in our area, in our design. So not only on the fiber level, you have all the coloring and configuration available. Of course, also for in this case, we're looking where we deployed microduct bundles. You can also see a detailed overview of how for each cabinet the duct bundles that leave the cabinet running to each home, we can see how each duct bundle is assigned to a building. Again, with all the coloring that is available, which is configured for each type of ducts that you have that you can use. So you can trace from, in this case, from DP 1.8, you can trace each home that is being connected, see which microduct bundle is being used, again with the labeling. So all of that detailed information is available, which helps you, which allows you at this stage to verify that everything is properly connected, in case you want to make some smaller changes maybe at this stage. But once you are ready with the verification of your to-build plan, make sure that you're sure that everything is properly connected, all the homes are being served in a correct way, and your cables are running correctly. Then you will have to generate or create all of the reports, plans, plots, which are needed for your construction teams to go out and deploy your network. And for this, we have our documentation pack creator. So if I just load this in, what does this do? Well, this allows you in one go to create all of the reports, all of the documents which are needed for the construction teams. So everything is created in a uniform way, so that you know there's no missing information. All the labels are correct. All the labels are correctly placed in the map, so that all the information is there, so that the construction teams know how to deploy the network as designed. So this allows you to generate all of this in one go. And if we take a look at everything that comes out of this, so what we have here is a couple of examples which are being generated with this documentation pack client. So what we can then generate is for every distribution cluster, we can generate the trenching that will need to be done. So this can be then used maybe for doing permitting, to know to verify that you have permission to trench at these particular locations. Also, of course, the splicing reports are generated automatically. So this is for every closure in our design. You get this kind of splicing overview with all the coloring and labeling, so that you know how, so that the field crew knows how to splice the fibers. And other things that can be generated, like we already saw the closure splice plan, which we already opened once, and then also another map, so you can style the plots the way you want it. So you can indicate which information that needs to be visualized. So for the permits, we just had the trenching locations. In this case, we have a lot more detailed information, where we can see the drop cable that needs to be deployed. You can see a section here yeah, how the microducts are being utilized in this segment. And again, this is easy to configure in the solution, so you can indicate which plots you want to show. You can set the layout, set the type of model, so you can. This is a one-time configuration again, like it is with the transformation from high-level design to low-level design, as it is with the configuration of the architecture in the high-level design. So a one-time configuration which saves you a lot of time when doing when generating every single design that you need in your region. All right, so with this demonstration, I wanted to show you that with the engineer, you can save more on your deployment costs with the high quality plans, high quality designs, by being able to verify that everything is connected correctly, that the coding is done in a uniform way, that your plans are being generated in a uniform way. You can save a lot of time in your deployment, and ultimately also money. What is saving you a lot of time in the design stage as well is the automatic way to create all of the plans, the import which is done automatically, the naming that's being applied automatically, so that you don't need to go start off with your design and try to generate your splicing reports manually in Excel, which takes a lot of time, which is error prone. So this we want to be able to cover with the engineer, so that you can automate this process and make sure that everything is correct. And again, this is offered as desktop application. You have full access to all of the data, all of the design, so you can edit as much as needed immediately, and update all your plans, so you have full ownership over your designs. All right. As a final point, I want to get back to the FTTx project workflow. So what we covered today was the designer and the engineer. Like I said, we also have the simulator to cover everything from planning up until build. What is important to know is that we have a couple of integrations with inventory solutions as well, which are being used in the operational stage. So both from the designer into engineering an inventory solution, or from the engineer into an inventory solution, so that you can streamline that whole the whole process, that whole workflow. And we have a number of partners and integrated tools which cover specific applications that are needed in the workflow as well. For example, demand aggregation, which can be done during the planning stage, or tools for doing mobile surveys, tools for doing the workforce management. So we have a number of integrations available. So if you have questions related to that, please don't hesitate to contact me. All right, so that was it for today. Like I said, if you have any specific questions or you want to discuss your own project, please don't hesitate to contact me, my email address, or via our website. And I'll take some time now to check if there are any questions. If you have some questions, please feel free to ask them in the questions window on the right right-hand side of your screen. Okay, I see one question here. Is the FiberPlanIT Engineer available only as a plugin for AutoCAD, or is it available as a separate standalone software? So indeed, the Engineer is a plugin for AutoCAD Map 3D, which is the platform where it's built on. For the designer, we have our standalone tool in QGIS. We have the solution in AutoCAD Map 3D as well, as you saw. We have a couple of other integrated solutions as well, but the Engineer is based on on AutoCAD. So that's the platform that's also needed to benefit from the Engineer. Let me take a look. Another question, can we export data from Excel? So yes, if you have address information which is stored in Excel with lat long coordinates, you can import this into the tool. That's the sort of data I think of that you would store, that you would need to import. Exporting the data back to the Excel is also possible. What I showed you, the bill of materials available in Excel, and also the connectivity overview you can export to Excel. Another question I see here: does it provide a conversion from single line to multi-lines? Indeed, that is an option. So for your for the plans that you want to generate, if you need multi-line plans, there's functionality to create those multi-line plans. I think in the examples that I showed, those were all single-line plans with the labels, indicating that there are multiple cables in the same trench. But for visualization, needs, you can generate multi-line plans as well. Let me check here if there's one last question. So one question I see here: what is the price for the solution? So that's a good question. So the pricing is based on the size of the project that you're doing. So number of engineers working on the software and the target areas where you want to deploy. So I suggest to discuss pricing in more detail one-to-one. So I'll definitely get back to you to see if there are what the sizes of your project, and make sure that we can make you an offer so that that you can benefit from the Engineer. Okay, so that's about it for today. I see some more questions, but unfortunately we don't have time anymore. So I'll get back to you, back to each one of you via email. So tomorrow normally you can expect link to the recording of this session. I want to promote a bit upcoming webinars that we have planned. So next week on Wednesday, I believe, there's a general introduction to FiberPlanIT as well, but in Spanish. So I don't know if any of you speak Spanish, but that's targeted to Latin American and Spanish region. And then in 2 weeks' time, there's a webinar on LetLongo, which is a mobile survey solution which we integrate with. So that can be used for doing field surveys in your high-level design stage, where you can capture the information that needs to be fed back into your design to fine-tune your design. All right, so thank you everybody for attending this webinar. You can expect a recording tomorrow, and I'll follow up on the questions one-to-one. I hope you enjoyed it, and I wish you a pleasant rest of the day and week. Thank you.